Hello, everyone, and let me welcome you to this Zero Outage Industry Standard webinar. I am Daria Diktorenko. I'm Senior Marketing Communications Manager with Exactpro. It's amazing to be here, and it's my absolute pleasure to introduce to you today Iosif Itkin, CEO and co-founder of Exactpro. Iosif is member of the Zero Outage Industry Standard Governance Board, and he is also co-chair of one of the fixed trading community working groups concerned with questions of monitoring, onboarding, simulation, and testing. Now, Exactpro is an independent provider of AI-enabled software testing services for the financial sector. Here at Exactpro, Iosif manages business development, the delivery of strategic software testing initiatives and research in the field of operational reliability of high-load financial systems. More recently, Iosif has also been at the forefront of Exactpro using artificial intelligence to enhance our software testing offering on multiple levels. So without further ado, let me pass the word on to Iosif. Iosif, could you please start with a more detailed background on Exactpro, perhaps?
Sure. So Exactpro is providing software testing services for mission-critical technology in financial infrastructures, exchanges, and clearing houses. Operational resilience is very important for our clients, and we are very honored to be part of the Zero Outage community. I hope everyone who joined the webinar already knows about Zero Outage, but I will say a few words. So Zero Outage is an industry standard, open industry standard developed by collaboration of top technology companies focused on striving towards reducing business visible outages in technology that companies build and operate. Zero Outage industry standard is built on top of four main pillars. They are processes, platforms, people, and of course, security. The last webinar focused on the people pillar and in particular on the competency model in Zero Outage industry standard. Today's presentation elaborates this particular area, and we'll talk about interrelation between interpersonal competences that are required for software testers to work in mission-critical, high-stakes, zero-outage environment, and how introduction of AI techniques can contribute into software testing, and what aspects of the human's competences are relevant to improving software testing. So on the list, we can see a drill down into interpersonal competences by Zero Outage. And so the list is relatively long. We will not review all of them, but we will focus on those that are most relevant to software testing.
Could we try and guess what they are out of the list? Should we try and do that?
Probably.
So how about a sense of urgency, the first one? A sense of urgency to reduce business impacts, and I would say conflict resolution and mediation skills. That would be my guess.
Yes, and conflict resolution. Yeah, absolutely. These are the most relevant ones. I'll talk about sense for quality, learning from mistakes, and reliability and credibility. So what is quality? Quality is a value to some person at some time who matters. So quality is inherently subjective and relative. It is determined by whoever is using the product at the time, and the same thing can be perceived by having different quality at different moments in time. Say, if you have a race car and you mostly use it as a status symbol in front of your house, your perception of absence of the braking system is different from the point in time when you're trying to drive the car and suddenly find out that there are problems is in automatic brake control. So quality as value to somebody, and different people have different perception of what is important, what is less important, and that's why different people perceive quality differently. Also, different people, of course, have different values. It means that they value different things differently. And this is one of the reasons why in AI research community, they're struggling to define what are the best terms in applying to AI, whether it is ethical AI or it is a responsible AI. So ethical AI, we can say that different people have different, and different cultures have different ethical structure. So when we talk about ethical AI, which particular ethical code we are trying to take into account. And of course, when we talk about responsible AI, we talk about ethical code promoted and supported by big tech. But overall, quality is related to values. To understand other people's values, one has to show empathy. So empathy, the definition of empathy is to understand others. And it means that if we do want to have AI, so if we want algorithm, machine code to be able to assess quality, it needs to have empathy. So it is an important consideration when we are trying to build a software to test software. So it has to demonstrate empathy. So what are software defects, also known as bugs? Software defect is an attribute of a software product or service that reduces its value to a favored stakeholder, or it increases its value to a disfavored stakeholder without a sufficiently large countervailing benefit. A defect may or may not be a coding error or a functional error. Design, specification, requirement errors are bugs too. And there is a process focused on detecting defects, and this process is called software testing. Software testing is exploring software with the intent of finding bugs. Software testing is an empirical technical investigation conducted to provide stakeholders with information about the quality of the product or a service under test. So software testing is information service. The purpose of software testing work is to detect and describe defects in the software. There are three main dimensions to measure the quality or the value of software testing. It is quality, speed, and cost. So quality is being better at detecting and describing defects. So the main outcome of software testing is information. Software testing is information service provider. Software testers are information service provider. So quality of their work is measured at how good they are at detecting and describing defects. And of course, the value of information depends on its relevance. So the faster we are able to provide information to the key stakeholders, the more value this information has. And of course, the lower is the cost of obtaining information, the better, because it makes this information more accessible and helps its users to appreciate the information. Improvements across any of these dimensions can benefit people who rely on software testing services. Software testing on a practical level can be split into 3 steps. The first one is to select actions to perform. So we need to define what actions are available, which of them to choose, and in what order. The next is executing these actions against the systems under the test or the services under the test to explore what will happen. So first we design experiment, and then we run empirical technical exploration. So we can execute different types of actions: setup actions, experiment actions, and observation actions. And in modern world, in modern IT companies, this part, test execution, is highly automated. So we can consider complexity of this part as easy and mechanical. So it does not require lots of cognitive overload to execute a scripted set of actions. On the other hand, designing actions to take, generating actions to take, requires cognitive workload, and one can estimate the difficulty of this cognitive workload as medium. Medium in comparison to interpreting the outcome of the actions. So interpreting outcome of the actions is a hard part. So it's of course also cognitive workload. And the main problem is that while looking at results of the experiments, we are trying to detect and describe defects. And while we are trying to detect and describe defects, we are trying to evaluate whether something that we see decreases the value of the software and the service. And of course, it is both subjective, time sensitive, and a task that requires very substantial cognitive workload. So different steps of this process, of software testing process, require different levels of cognitive abilities.
Iosif, can we say, sorry to interrupt, can we say that we can trust AI to test software? So is it, can we automate it that much at this point in time?
Good question. Probably we'll get to it at some point. So what we can say is that AI already can do many things. So it can talk to you. It can drive a car relatively safely. It can classify images of cats and dogs. And there are many other very relevant things and that AI had accomplished. Also, there is a known effect that is called AI effect, that many tasks that we previously considered as having cognitive workload or requiring intelligence are no longer considered to be AI tasks or intelligent tasks, but rather they are considered to be simple permutation, searching, combinatorics tasks. Examples would be like 40 years ago, everyone would agree, and there was a consensus that playing chess requires high level of intelligence. Now, no one will say that it is a task only humans can accomplish, because we know that for the last 26 years, we were surpassed in this area. And something that we've considered to be a task that requires the highest top level of human intellect is no longer considered to be a task because computers can do it better. The reasons and the two main trends how it was accomplished are based on two foundations, two pillars. It is the growth of available digital data and also the growth of computational capabilities. The algorithms themselves were available for longer, so many of them were known in 70s. But there was not enough data and there was not enough computational capacity to really apply sub-symbolic tasks to sub-symbolic AI to the tasks that matter. With this problem as a result, we can see across all industries, across all sectors, sub-symbolic AI, also known as machine learning, can deliver benefits, efficiencies and improvements in autonomy across many industries. So with the modern CI/CD pipelines, it is easy to minimize human involvement in test execution part, but automating higher level cognitive functions such as test idea generation or results evaluation is of course a much less straightforward task, and it is the subject of research in many companies and of course universities, etc. So once again, if we can spot a cat or dog in the picture, surely we should be able to classify if we see a bug in the code or not. The task of machine learning is relatively straightforward. I recommend to everyone a perfect course of Introduction into Machine Learning by Casey Kozyrkov. And machine learning is label all the things. So you use machine learning when you're trying to put lots of labels on something. For example, you have a large set of images and you would like to put a number of labels on every image. So what you see, whether it is a face, whether it is an animal, or it is a landscape, whether it is bright or whether it is dark, etc. And in software testing, we also would like to put labels. So we run particular actions against the systems, and we would like to be able to assign labels. So one can expect, why not we assign label test pass, test fail? We'll get back to it later. But we can assign labels that define the probability of or potential for the problem in the data set that we see. So when we do have sufficient computational capacities in our test environments and injectors, and when we do have enough data, either available or generated or handcrafted, when we do have enough data, it is possible to use machine learning to label events that we see in the systems under the test during the exploration. So machine learning is label all the things, and using machine learning in software testing is labeling inputs, outputs, internal states, pieces of documentation, and everything else in order to convert a cognitive task into machine learning task. And we already know that some tasks can be reformulated to be a machine learning task. So we can replace human intelligence with combinatorics or using methods like machine learning. So this diagram shows example of using machine learning to software testing in stock exchanges. The idea is to label all inputs, label the test basis. So test basis is everything our software testing is based on. So it can be the list of equities, derivatives, other instruments, and their trading control permutations. It is the list of users, their trading control permutations, all reference data actions, all protocol specifications and machine-readable dictionaries, various checklists used by market control users or other operational teams. The next step, we can say it is a large piece of data, but is it large enough? To produce more data, there are many possibilities, from just generating random synthetic data, using Cartesian permutations, using more efficient or less heavy, not as heavy methods like all pairs, pre-filtering, etc. So it is possible to produce huge input data sets. Then these input data sets are executed against the system under the test, and they produce output data sets. The secret sauce of producing output data set is to have a unified data warehouse. So you can structure all the data collected from observations inconsistent format. So you are not having multifaceted sets of data, logs separately from traffic separately, network traffic separately, or some internal events, changes in the databases, all in different formats. You need to bring everything into the same storage where input data set is stored. So it is possible to go to the next step. And the next step is to take a large set of data and produce interpretation data set. Interpretation data set is usually produced by property checking and annotations, and also by using model-based testing and simulation to generate expectations that can be reconciled against observations from the system under the test. It is often possible to reconcile different data streams to both that go in one direction, for example, different pricing and quotation channels, but also input and output streams. You can reconcile what is sent into exchange by brokers, members, and also what is output from the system. Important insights can be obtained by aggregating data and also reconciling aggregated data against different types of data, exploring for anomalies and trends. So once interpretation data set is produced, it is possible to use it as a part of reinforcement learning and produce weights data set that is used during the next iteration to improve script selection. So to improve the process of selecting actions and organize them for the test execution. So the idea of using machine learning for every task is to try to reformulate it as a labeling task. And the task of creating data sets. So there are different types of machine learning that can be used to do it. And it is possible to use supervised learning where we both manually or using scripts annotate large sequences of data that are later used in machine learning process. It is also possible to use unsupervised learning, where we first produce large output data sets, and then we are trying to find trends and patterns in the output data set. And of course, to improve software testing. So software testing is relentless learning. We can use collected data sets and the output of the interpretation to produce weights data sets to be used in reinforcement learning. The process of using machine learning in software testing is the process of producing large volumes of synthetic data. Synthetic data in this case is every input action or any output observation is annotated by a number of labels. Synthetic data in general and test data in particular has several features that define its quality, so its value. These features are fidelity, utility, privacy, and explainability. So fidelity is, of course, how close the data that is produced by computer to the data that we observe in the real world or that is handcrafted by humans. There are types of testing where fidelity is more important. For example, when we are trying to simulate the behavior of the market under load, and we would like to have load distribution by transaction types to be very realistic to measure what are expected latencies. Round-trip times will be observed by participants. In most of the functional testing, utility is a more important feature. So utility of synthetic data is whether it helps or hinders our ability to do something. In software testing, our main focus is finding and describing defects. So if the data that we use or the data that we've produced helps us to detect defect and helps us to describe what we see, this data has utility. So in many cases, utility is more important than fidelity. Of course, then there are questions of privacy and responsible use of the data. We do not want to expose other people, other companies, and communities to violation of their privacy, or we should avoid at all costs jeopardizing other people's interests and creating data sets that will allow to identify sensitive information about people. So it's very important to always consider privacy concerns when dealing with large sets of synthetic data. Even in the modern world of trading algorithms, you can say yes, so there is no privacy in transactional data sent by the robots, but often even this information can result in identifying patterns that are important to particular members. And so in every area, privacy is an important aspect of dealing with synthetic data. And the last one is explainability. It is so human mind, a model of human mind is and human thinking is operating two systems. One of them is system 1 and system 2. So system 2 is responsible for rational thinking. And the key aspect of system 2 is that it has very limited throughput. So the system 1 is responsible for moving, breathing, image recognition, etc. System 2 is responsible for what most of us consider to be cognitive functions. And of course, system 2 has very limited throughput. And it also gets tired very often. And it has many other limitations. So when we deal with large volumes of data produced by computers, it is necessary to make sure that system 2 in human's brain is capable to understand the data and to understand the sequence of steps that led to particular data. And in many sectors, ability to explain why the algorithm gives us one output or another is extremely important. And software testing is, of course, not an exception. The next one is, of course, learning from mistakes. It is a part of interpersonal competences. What is machine learning if not learning from mistakes? But what is more important is that most living algorithms are not learning from good things. People, animals, we all learn from bad things. So if something bad happens, we do not want to repeat it again. We want to avoid it. And it creates additional neural paths in our brain. Yes. So production services usually operate in good way. So at least we hope it is the case. In test environments, we have more problems, more errors, and there are more opportunities to learn from what we have in the test environment. But in fact, there is a Japanese mantra is to live an honorable life, one has to always think about death. And the same goes to operate in resilient systems. So to operate, to build and operate mission critical, highly resilient system with high availability, one has to always think about outages and what can possibly go wrong. And this brings us to the next question of what is the most important in this area, and another interpersonal capability that is required from people working in zero outage environment is reliability and credibility. There is a common consensus now that some AI systems, or most AI systems, such as large language models, are both non-reliable and not incredible, but not credible enough. So, of course, the best way to figure it out is to ask one of them what it thinks about reliability and credibility. The funny thing here is that it immediately links reliability and credibility from responsibility perspective to domains of information, communication, and professional domains. So software testing is information and communication domain. And that's why one of the things to be both reliable and credible is to have responsibility. It's not easy to define what responsibility is. My favorite definition and description of responsibility is based on the book, the research related to the responsibility process that consists of 6 steps, ranging from denial, blaming, justifying, shaming, quitting, and going into responsibility. If you look at this process, you will see that, of course, software systems can easily deny things or lay blame But things like shame is inherently human, and also taking obligations, making promises to do something is more human. So it is a responsibility process. Why I'm fascinated about it is, of course, because it has at its foundation that something bad had happened. Something bad like software outage had happened, and now you are looking at it, and human brain is trying to find explanation to why this particular outage had happened. And most of the time, the explanations start with denying that there was a problem, and then to find who is guilty or what is guilty. So there is either somebody or either someone or something who are responsible.
Iosif,
Yes.
yeah. Do you have like a particular I'm not going to say favorite, but like an outage you would like to highlight?
Yes, so probably included
I'm sure
in
you've seen many.
every other slide deck. So my most favorite outage is the one that happened 11 years ago on 1st of August in 2012. It is known as nightmare, crazy bot, AI disaster, etc. So the problem was that on the 1st of August, one of the most successful high-frequency trading companies deployed a new version of their software. And this software was responsible for routing orders from clients into different markets. So it was smart order router. And due to incorrect deployment of the new version of the software, it resulted in sending millions of incorrect orders into the market. It resulted in losses of $450 million within 45 minutes. So it is more than 150K every second. And everyone who is looking at reports produced by Securities and Exchanges Commission see different things and different aspects what could have possibly go wrong with this AI trading system, but the aspect that I enjoy most about this particular problem is that on that very day before the disaster started, according to investigation, in the morning there were emails received an hour and a half before the disaster started, and there was a set of 97 emails describing that particular functionality is disabled. So, in the matter of fact, these emails were never received before for many years. And one can argue that AI system had provided information that something is wrong. And then humans just have not reacted on this information. So there was a potential opportunity to identify and fix the problem before the market opening. But no one essentially opened the email. And responsible behavior requires many things, and it requires to go beyond the stages of irresponsible behavior. And the stages of irresponsible behavior are like trying to guilt yourself, taking guilt or making promises is of course inherently human, but they are not something that can be easily replicated in the software. To act responsibly, we as humans developed systems of motivation for other humans. So if you are not acting responsibly, there are things that society can do with you to make sure that you behave better. And there are social benefits for somebody to act responsibly. So if you are responsible for mission critical system and you apply proactive approach to make sure that there are fewer business visible outages, there are social, financial, and other incentives for you to act responsibly. There are no incentives for software code to do something. So we learned how to teach humans to act responsibly. And we also know that very often they act irresponsibly. But it is not something that we can teach a computer to do. That's why there is an important concept called test oracle. So test oracle is something that is used to describe whether the observed behavior is the problem or not. And in fact, some people who think about using AI, using machine learning in software testing, they consider that the task we are trying to solve is to build a classifier to say this is a bug, this is not a bug. In reality, software is not able to evaluate, to demonstrate empathy, to demonstrate responsibility. And what we need to think about test oracles from as a classifier or regression method that gives us the weight of for involving responsible entities. Responsible entities are humans. So when we build machine learning based, or not necessarily machine learning based, but any other algorithm based system used in software testing, what we need to really calculate is the probability, the weight of that it is a good idea to involve humans, somebody who is responsible, but who has very limited system 2 capacity, so limited cognitive and processing capacity. The method of using machine learning in software testing, we are labeling all the things, and then we are trying to use these labels to predict that in this particular area, it would be a good idea to involve a human to have a look and see if there is something that decreases the value of the software to other humans. And only humans can be responsible. There is no such thing as responsible AI. Responsibility requires personhood. And it is easy to explain why it is possible to get responsibility from a human. It is possible to get responsibility from a human because humans can be reasoned with. They can feel pity, remorse, and fear, and they will eventually stop. In contrast to that, software cannot be reasoned with. It feels no pity, no remorse, no fear. It will never stop. So just using things like machine learning in software testing is often can be seen as automating irresponsibility. So, and software testing, good software testing that provides value, software testing that provides information to other people, it is only as good as if it is provided by a trustworthy, credible, and responsible people. It is not possible to investigate modern systems. So if you have a system that consists of 100 different components interconnected between each other and also connected to external upstream and downstream systems, it is of course not possible to just rely on human brain to explore what can potentially go wrong with the system. But the ultimate responsibility for exploring, for configuring data processing and exploring its outcome lies on humans. So you know that until recently, many decisions in social networks were always explained by the algorithm. So this decision was made by the algorithm, that decision was made by the algorithm. In reality, all high-stake decisions that worth making should be made by a human, somebody who can feel pity when the decisions appear to be wrong. That concludes my presentation on using machine learning, AI in software testing. Thank you very much.